first thing is let's just sort of read and interpret what's going on here. So we've got a function f, and that's what our graph is. It's got a couple of line segments, and it's got a quarter of a circle that's centered at the point 5,3, right? So that circle would be centered at 5,3, and we know the value of the point at 3. And so the first thing that this is asking us to do is to find the value of the integral from -6 to -2, given that we know the value of the integral from -6 to 5 of f of x. So if I know what it is from -6 to -5, I should be able to write out a set of two integrals, one that involves the integral from -6 to -2, which is what I'm looking for, and one that would then be what?
-2 to 5.
-2 to 5, exactly. And so now, if we want to find the value of the integral from -6 to -2, we just need to do the integral from -6. No, that's not a negative, that's a positive 5. From -6 to +5 minus the integral from -2 to 5. So -6 to +5 is 7 minus the integral from -2 to 5 of f of x dx. So everybody good that that's what we're looking for here?
Yep.
All right. Well, what's the integral from -2 to 5? Well, it's just the area between the x-axis and the curve. Anything above the integral will come out to be positive. Anything below the integral will come out to be negative. So from -2 to -1, and from -1 to 0, we got two little triangular sections which are identical, except that one's above the x-axis and one's below. So what'll happen with both of those?
They essentially would make a square.
Well, let's think about, we're thinking about one of them is above the x-axis, which makes it positive. The other is below the x-axis, which makes it negative, right?
They cancel each other out.
They should cancel each other out. Right. Same thing should happen with this little triangle here and this little triangle here. One of them is above, one is below. Those should cancel each other out as well. Do y'all agree with that too?
Yes.
Okay. So then all that's left of the integral from -2 to 5, once I've taken care of -2 to 1 being 0, is from 1 to 5. And so from 1 to 2, that's just a trapezoid, right? So that ought to be the first base of 1 and the second base of 3 divided by 2 times the height, which is 1. And then this other chunk down here that's underneath this quarter circle, well, that ought to be the whole square minus the quarter circle. And so the whole square ought to be 9, and the quarter circle ought to be 1/4 pi times the radius squared. And so if we simplify all of that down, we ought to get the value for A. So that gives us 7 minus, this is 4 over 2 is 2 times the 1 is 2, so 7 minus 2. And then we've got here a 9 minus whatever this value there is. So minus 9, and what is that? Plus 9 pi over 4. We distribute the minus sign through. And so we should end up with a final answer of what?
-4 plus 9 pi over 4.
Perfect. Everyone good with that?
Just a question. On like diagrams like these, is it okay to assume like certain x values at points, or do you have to, or can you not assume things if they don't give it to you?
you cannot assume things. Now, I mean, like clearly that point is that point, that point is that point. I mean, you know, they've indicated those points at 2, 3, 5, 0, 0, -1, and -2, +1. So, I mean, those you can assume are those points that are listed there. Anything that's along the line, I mean, you should be able to find just because you know this is linear and this is linear. Right? It says 2 line segments and a quarter of a circle. If it didn't specify that that was a line segment, then you cannot assume any of those points. Does that make sense?
Right. So like you can't be like, that looks like it crosses at 0.5, so I'm going to put 0.5. You can't do that.
You can't do that unless you know that it is linear, which you know that it's linear, so you can guarantee that it does. But if it didn't specify that it was linear, you could not just assume that was 1/2. That was the x-intercept there. Does that make sense?
Yes, thank you.
Mm-hmm. All right, so part A was worth 3 total points. 1 for having this integral to set up to begin with. 1 for finding this 9 minus 9 pi over 4 value. And 1 for your final answer. Good or no? Okay, actually, it was actually 1 for all of this value, not just the 9 minus 9 pi over 4. It was the 11 minus 9 pi over 4. All right. Part B says to evaluate this integral from 3 to 5. Well, that should be pretty straightforward. We can rewrite this as 2 times the integral from 3 to 5 of f prime plus the integral from 3 to 5 of 4. And what's the integral of f prime? Should be
F of x.
Should just be f of x. And so we're going to evaluate that at the upper limit and the lower limit. And then we will add to that this integral, which is 4x from 3 to 5. And so now we've just got 2 times f of 5. So f of 5 is what? Should be 0. And f of 3, well, we can't assume that, but luckily they give us that point. And then plus 20 minus 12. And so what do we end up with there? We got a positive 8 there. We got a 2 times a negative 3 is a negative 6. That's a positive 2. A negative negative on the root 5 makes it positive, times the 2 is 2 plus 2, 5. Good on part B or no? Any questions there? All right. Part C says we got a function g. G is the integral from -2 to x of f of t. Find the max, the absolute max of g on the interval from -2 to 5. So one thing, first off, since this is a closed interval, we are guaranteed that there will be an absolute max on the interval and an absolute min. We only need to find the absolute max though. And to find out any places where it could occur, we need to check endpoints and we need to check critical values of g. So g prime is f of x. If you just take the derivative of this, right? That's the first part of the fundamental theorem of calculus. So we want to know when is f of x equal to 0 or when is f of x undefined. And so f of x is equal to 0 at -1 and at 1/2. F of x is never undefined on the interval from -2 to 5. And so for part C, we're just going to say, here's x, here's g of x. We'll test the endpoints and the critical values. So at -2, remember that g of x is just the integral from -2 to x of f of t dt. What's the integral from -2 to -2 of f of x, or of any function? Should be
0.
0. Great. And then from -2 to -1, this value should be 1/2 base times height of this triangle. So base and height are both 1, so 1/2 of 1. So this is a half. So clearly our absolute max couldn't have been at -2. Then we'll plug in a half. So integral from -2 to a half. So -2 to 0 cancels out. 0 to a half gives me a triangle that's below the x-axis. So it's going to be a negative value of a half times 1 times a half. So -1/4. So also not a max. And then for 5, we're looking for the integral from -2 to 5. Well, we already did that integral a little bit ago. Right, this was 11, and this was 2 plus 9, 11 minus 9 pi over 4. And 11 minus 9 pi over 4, we ought to easily be able to tell that that is greater than 1/2. So we don't have a max there either. We have a max at x equals 5. And that was worth 3 points. 1 for showing this. 1 for identifying that -1 was a potential value, and 1 for determining that the value at x equals 5 was the actual value. Any questions there on part C?
So -1 and 1/2 were the times when f of x was crossing, or those are the x-intercepts, right?
Those are the x-intercepts, right? That's
Okay.
when f of x equals 0, which since g prime is f, the critical values of g are the places where f is equal to 0. So -1 and a half. And you could have not even bothered to check the value at at 1/2, because you knew that the derivative was going from negative to positive, which means you should have a minimum there. But plugging it in and getting that value is not that big a deal. Yeah.
Okay, thanks.
Yep. Kylie, I'm not sure what your question exactly is. Can I re-explain how I got g of x? I mean, g of x is given to us. So I guess I'm not sure what you're asking me. For the table, you mean how did I find these values? Oh, I plugged it into this integral. So the integral from -2 to -2 of anything is 0. The integral from -2 to -1 of f, right? This is the integral of f. So the integral from -2 to -1 is just the area between the function and the x-axis, right? That's what an integral is. It's the space between the function and the x-axis. So I just plugged it in. Everybody good there now? All right, and then part D asks us to find the limit as x approaches 1 of 10 to the x minus, or was it plus, minus 3f prime of x over f of x minus inverse tangent x. So first off, 10 to the x is just 10. If x is 1. And then this is 3 f prime of 1 over f of 1 minus pi over 4, right? Inverse tangent of 1 is pi over 4. So f prime of 1 is the slope of f at 1. Well, the slope of f at 1 is the slope of this linear piece. Slope of that linear piece there is a rise of 4, run of 2. That's a slope of 2. So we have 10 minus 3 times 2. And then f of 1 in the bottom there, f of 1 should be 1. If you just look at the value there, should be 1 minus pi over 4. So we end up with 4 over 1 minus pi over 4. And most of the time, these limits, when they just throw these random limits in, they'll often come out to be ones that need L'Hopital's rule, but don't assume that they do. Just remember that that's a possibility if it's 0 over 0 or infinity over infinity. But in this case, you didn't need it. Any questions there with part D? All right, so we've got the graph of a continuous function g, which is the derivative of f. Okay. So I'm going to say g is the derivative of f. So f prime equals g. We're just going to kind of write that down. That's helpful probably. And then we know that g is piecewise linear from -5 to 3. So all these things are linear pieces. And then it's parabolic 2 times x minus 4 squared from 3 to 6. Okay. So the first thing we want to do is figure out the value of f of -5, given that f of 1 is equal to 3. So in order to figure out what f of -5 is given some value of 1, we're going to have to use an integral in some way. So we know that the integral of f prime should be the integral of g, right? And the integral of f prime, or the integral of g, should be the values of f. So if I were to make this, let's say, from -5 to 1, then I could write this as f of 1 minus f of -5. Everybody agree with that?
Yes.
Cool. And we want f of -5. So f of -5 ought to equal f of 1 minus the integral from -5 to 1 of g of x. So we know what f of 1 is. It's 3. We just need to subtract the integral from -5 to 1 of g of x. So anything that's below the x-axis has to be negative. Anything above the x-axis will be positive. And we're going from -5 to 1. So -5 to -1 is all below. The first part of it there is a square that's 9. So that's -9. And then we have this little triangle here, which should be 1/2 base times height. So that should be -3/2 since it's below. And then from -1 to 0, it's just on the x-axis. So that's just going to stay as is. We're not going to add or subtract anything to that. And then this triangle above should be a positive value. And base is 1, its height is 2. So 1/2 1 times 2 is a positive 1. And so we'll just simplify that out and get an answer. 3 minus -9 is positive 12, which is 24/2. We're going to add 3/2 is 27/2, and we're going to subtract 1 to get 25/2. Any questions there on part A? Okay. Part B, we want to evaluate the integral from 1 to 6 of g of x. Well, the integral from 1 to 6 is just the area underneath the curve from 1 to 6. So the first piece is the square, so that's 4. And then we'll add the integral from 3 to 6. of the parabolic function. And so splitting it up was worth a point. Oh, I didn't give you guys the point breakdown for part A. Part A, point breakdown was, what do they have here? I don't know, it just says integral for the first point of that. So I don't know, maybe if you, I think if you set this up, that's worth a point, and then the final answer was worth a point. And so on the second, for part B, having this split into two integrals was worth 1 point. And then correctly integrating 2 times x minus 4 to the second to give you 2/3 x minus 4 to the third was worth a second point. And then correctly evaluating it in the end is the last point. Whoa, I don't know what happened there. So that gave us 4 plus, and then 6 gives us 2 cubed, or 8. And then 3 gives us -1 cubed, or -1. So +1, if we're going to subtract, minus a -1. 9 times 2 is 18, over 3 is 6, plus the 4 is 10. And that's your final point for part B. Any questions there on A or B? All right, so part C asks us for any places where the graph of f is both increasing and concave up. Hold on 1 second, please. I need to deal with an issue in my house because one of my children doesn't seem to know how to behave right now. Sorry about that. All right, let's get back to part C. From -5 to 6, we're looking for places where f is increasing and where f is concave up. So if f is increasing, that should tell us that f prime is positive. And if f is concave up, that should tell us that f double prime is positive. So we can correlate that up here. F prime is g. So if f prime is positive, then g is positive. And if f double prime is positive, g prime needs to be positive. And so this is saying that g is above the x-axis. And this is saying that it has a positive slope. So g is only above the x-axis from 0 to 6, except for at 4 where it's on the x-axis. And then it has a positive slope, well, from 0 to 1, and from 4 to 6. But from 1 to 3, the slope is 0, and from 3 to 4, the slope is negative. So those are the places where f is increasing and concave up. And that was worth 2 points. one for having the correct intervals and one for some reasoning. So really all of that right there is the 2 points. Good or no? Everyone good with part C?
Yes.
All right, part D. Part D says find the x-coordinate of each point of inflection of the graph of f. So a point of inflection can potentially occur when the second derivative is 0 or when the second derivative is undefined. Right, so we are first off interested in f double prime equaling 0 or f double prime being undefined. But in addition to that, we know that f double prime needs to go from positive to negative or negative to positive at that point. Not just that it equals 0 or is undefined, but it has to actually have a sign change, which means since we're talking about f and f double prime is equal to g prime. So we are interested in when do these slopes of g change sign. So that's what we're trying to find. Does everybody understand that that is the correlation between f double prime and g prime, and f being, or f having a point of inflection, so g prime needs to have slopes that change signs on g? Everybody good there?
Yep.
Sorry, say that again?
Yes.
Yes, okay, yes, okay. So we look at g, and here the slope is 0, and here it's positive. So anywhere where this is going from 0 to positive, well, that's not a change in sign, right? It's not going from negative to positive or positive to negative. It's going from 0 to positive, so no. And then it's going from positive to 0 at -1. And then that's not a change in sign. Then it's going from 0 to positive again at 0. And then it's going from positive to 0 again at 1, and again, not a sign change. Then it's going from 0 to negative. But then down here at x equals 4, the slopes of g go from negative to positive. Right? So that only occurs at x equals 4, even though there are a bunch of other places where f double prime is 0, so where g prime is 0 or where g prime might be undefined. But the only place where there's actually a sign change is at x equals 4. Good or no? That was worth 2 points. Any questions on that? All right. Got time for you guys to work through this one. We won't have time to talk about it today, but this will be the first one that we talk about tomorrow if we finish the multiple choice, or the first one we talk about on Monday if we take all period for the multiple choice. So I want you guys to spend the next 15 minutes before class is over working through this one.